It's just me.
One.
So C1 is going to be our initial concentration, which is going to be this stronger
Oh, the stronger. Okay.
50x. Does
The
that make
50.
sense?
Okay.
So,
Yep.
so 50x is what you would put for C1, and then V1 is what we're going to solve for. Okay? The final concentration that we want is what? 1x,
One
exactly.
X.
Yep. And the total volume that we want to make according to this problem is 200 milliliters. Is everybody okay with that?
Yep.
So then,
Can you please repeat that again, ma'am? Let me check that I have it right.
so I put it here. I want to make sure you guys can see that. So 50x TAE is that initial stock solution concentration. That's the bigger number. That means it's more concentrated. And then V1 is what we're solving for. 1x is our final concentration.
Can I pause you for a sec?
Yeah.
If you guys need your screens a little bit bigger, you can hover over her and then click the three dots and pick pin, and then it will make her like the main screen.
Oh, so they can see my numbers?
Yeah, so it just makes your math a little bit bigger.
Okay.
Thank you. Yes.
And then 200 milliliters is our final volume that we want to make. So if you work this like a math problem and we're trying to get V1 by itself, right? Then we would divide both sides by 50. Are you guys okay with this?
Yep.
Tricia, can you show
Yeah.
me your worksheet again with the problems? I'm not looking at the right problem, I don't think.
It's the one that says at the top, gel electrophoresis solution dilution worksheet, and it's double-sided.
Yep, got it. Okay, great.
Okay.
Thank you.
You're welcome. So, that if you solve for V1, it should end up being 1 times 200, which is 200, divided by 50. So your V1 is 4. So what that really means is for 200 milliliters that you want to dilute, you're taking 4 milliliters of the fully concentrated and adding that to water to make it a diluted version. Okay. With my students, sometimes they have a hard time wrapping their minds around it, and it's kind of hard when you're doing this with TAE that's clear and water that's clear. But if you take a beaker of like food coloring water and you're like, okay, this is 50x, right? And then you give them this problem and they do it, essentially they're going to take 4 milliliters of that dark food coloring water and add it to 194 milliliters of water. And then they can visually see that color change from like a bright red to a very light red. And it helps them, I guess, see that you're going from that stronger concentration, diluting it. I don't know if that makes sense.
Yes.
Okay. So the part B of this question says, what are the steps needed to make that? So basically what you would do is you would have your 4 milliliters of the 50x TAE and you would add 196 milliliters of water. So the total volume is up to 200 milliliters. If you did 200 milliliters plus the 4, then it's going to be less than a 1x. Does that make sense? It's going to be a little more diluted than what you originally want. So
Yes.
when you have that final volume, like that is the max. That's what you're making total. Okay?
Yep.
You guys feel okay with that?
Yeah, that's helpful. Thank you.
Okay. So now it's like pop quiz time. So if you flip the sheet over, question 3 is another TAE dilution C1V1. So I'm going to see if you guys can work that out, and then we'll get our answers together. And there's a trick in this one. Do you guys have are you working it out?
Yes.
Anybody getting their answer?
I converted to milliliters.
I love it. I always convert it to milliliters. But if you didn't, we have it both ways,
Okay.
and they
So I'm gonna say 20 milliliters.
that is exactly what I got.
Ding, ding, ding.
And then the other thing is if you I think you guys need it this way. Is that right for you? Yeah.
Mhm.
The other way, if you leave it at 1 liter, it ends up 0.02, which is 20 out of 1,000. So it's still like 0.02 liters is 20 milliliters because there's 1,000 milliliters in a liter. Does that make sense?
Yeah.
Okay. All right. So the second bit of math, and then we'll go ahead and get started on making our gels. The second bit of math.
Hold on. Can you
Oh, yeah.
slow down just
Oh,
a
yeah.
second?
Yeah, sorry.
Can you slide your previous paper? Yeah, sorry.
Yes.
I want to grasp it, and I'm very slow with. I'm not a science teacher, so this is not natural.
No, and
I'm getting it.
this math, if I'm being honest, when I first started teaching biotech, this math freaked me out because it was all of these like, well, 50x and 1x and 25x and like 500x of this stuff. And I'm like, what are we even talking about? Like it took me a minute, and I would always double check my math with my husband. And I also had an amazing student teacher at the time, Amanda Barrett, who had a lot of this biotech background, and she saved me, she helped me, she worked things out. She was patient with me. But it takes a minute because you're like, well, we're talking about this, and some of you guys, if you haven't been in biology in a long time, you're like, well, first of all, what the heck is 50x TAE? Like, what am
I'm
I?
not even worried about that.
So anyways.
Yeah. Okay, I'm good. Thank
You're
you.
good? Okay. But yeah, this math, like this kind of stuff, like making these things always made me nervous when I was starting. Like I was hesitant. It took me a while to double check everything.
Now
So,
you're a pro.
hey, I'm working on it. Kroger coupons in the car, you know. So Are we good to move to question 2?
Yes.
Okay. So, question 2 says the gel box for the dye separation lab requires 60 milliliters of a 1% agarose in 1x TAE buffer solution. How much agarose is needed? And this is another one of those things. It's like, if you don't have to math all the time, you're like, my math isn't mathing. But I always said I'm like, slow with math. I have to write everything out real long, and my kids do it in their heads. And anyways, so if the question is asking you to make a 1% solution, I always think like money wise, like what is 1%, right?
Mm-hmm.
So if you think about 1%, it is 1 part out of 100, right? But so that's 1%, but this doesn't need 100 milliliters. If it did, we would just have 1 gram of agarose in 100 milliliters. That's 1%. This is asking for 60 milliliters. So if you make a what are these? Cross multiply equal. I can't use my math terms right now. Then you need to figure out how much agarose is needed for 60. And some of you are like, well, 1% of 60 is 0.6. If you need to do the equals, like I always double check myself with, 1 out of 100 is 1%, and 0.6 out of 60 is also 1%. So then those two ratios, I guess, like are equivalent to one another. Does that make sense?
Yes.
Okay. And then for describing the steps to make it, you would simply weigh out 0.6 grams of your agarose and add it to 60 milliliters of water, essentially. In a perfect world, you would take like a flask and put your grams in there and then raise it up to 60. But sometimes that's hard with our like glassware, to be exact. You guys okay with this?
Yes.
Okay.
I think I am, but my ignorance, because like agarose, I don't even know what that is. Apparently, it comes in grams, so we
It
moved to a
does.
weight now.
It is.
I
Yes.
don't see grams anywhere in the equation, and then the answer is in grams, and I'm like, wait a minute. Okay, thank you.
That's okay. Yeah. And for reference, when we start getting our gel together, you guys should have this small like Eppendorf tube or centrifuge tube that says 0.7 grams of agarose. So this is what we'll use in a little bit. And this is our conical tube of 50x TAE. Liquid, solid, got all the things. Okay. All right. So if we flip to that back again, there's another question, and it's just like the one that we did, different values. So I'm going to give you guys a minute, make sure you can do that, and we'll talk about the answer, and then we'll start making our gel.
The number 4?
Number 4, please.
Yes.
Anybody done calculating?
1.
1 gram.
I got 1 gram. So if you guys look at the math, and I always do it my long way. 2%, 2 out of 100, but we only need 50 milliliters. So I'm solving for X. And when you cross multiply, you get 100 divided by 100. My husband teaches the honors chemistry, and they have to do all that stoichiometry stuff, and my mind works much better with just cross multiplying for what I need. So I don't know, but you guys okay with this?
Yes.
Yes.
You ready to get the hands-on part?
Yes.
Okay. So in the binder, you guys should have seen for today, you need our TAE buffer, which is this. We need our tube of agarose, which is this. You guys will need your small soapbox, which is this. You will need your plastic beaker, your graduated cylinders, and your comb. Does everybody have everything? Okay. So what Cynthia and I checked was she had measured out that our box, what we need to do is make about 70 milliliters of a 1% gel. But we're going to break that down. So a 1% gel has the 1% of the total of agarose, but it's also made with 1x TAE. So if you guys, what we decided that we were going to do is have you guys make 100 milliliters of 1x TAE. So if we do the math and we can kind of do it together, our concentration of TAE for the lab is 50x again. We're going to solve for V1. Our final concentration is 1x, and we're going to ask you to make 100 milliliters. Keeps the math pretty simple. So if we solve for V1, what do you guys get? 2, right? So V1 equals, that's upside down for me, so don't judge the 2. 2 milliliters. So if you take your 100 milliliter graduated cylinder, what we can do is, and you guys can kind of decide how you want to do it. You can use a disposable transfer pipette. If you want to grab 2 milliliters, you can use your 10 milliliter graduated cylinder for 2 milliliters. But essentially, we are going to have 98 milliliters of water and 2 milliliters of 50x TAE. So in my 100 milliliter graduated cylinder, I am adding 98 water and 2 milliliters of 50x TAE. Okay. Let me know when you guys are ready. Good?
Yes, ma'am.
Yay. Okay. So now that we have our 1x TAE, we can work on making our agarose. So, again, kind of what we thought was the easiest math is if we have 100 milliliters of 1x TAE and we need a 1% agarose, then we would take 0.7 grams, which would be all of your tube, and mix it with 70 milliliters of water. So if you guys have the plastic beaker, I couldn't find my plastic one. I just grabbed a glass one. But if you guys have your plastic beaker, those are perfect. And if you would like to pour all of your agarose into the bottom, and then take your TAE, 1x TAE that we just made.
Y'all put on y'all safety glasses.
Yes, thank you. Gloves and goggles. My goggles were used by a student today. Let me grab these. Thank you, Aaliyah.
No problem. Safety first.
Yes. And then we'll take 70 milliliters of our 1x TAE and pour it into mix with our agarose. Down to 40.
I have a question.
Yeah.
Where did you get the solution to mix with the 98 of the liquid?
So it would be 2 milliliters of this 50x and
Oh,
98 water.
is that the buffer?
Yes.
Oh, okay. Because my top is blue. That's what threw me off.
Sorry, yeah, mine's yellow.
Okay, I gotcha.
Okay.
All right, let me mix that.
And you guys should have kind of a cloudy looking,
Mm-hmm.
gritty looking solution.
Mm-hmm.
Is everybody's like that?
Yes,
Yeah.
ma'am.
How much we are taking this 1% solution?
So your
Right?
1%, you're going to use 70 milliliters of it with your 0.7 grams of agarose.
All of the agarose and 70 ml from this.
All of the agarose, 0.7 grams, and 70 out of the 100 that you made.
Mhm.
And that should give us a 1% gel. Is everybody good?
Yes, ma'am.
Okay, so here's where lab safety, I didn't have my goggles on, but I would in a second. Here's where lab safety gets a little like flash boiling can happen with if you're making like agar for bacteria or agarose for gel electrophoresis. So in a couple minutes, you guys are gonna microwave this, but you need to the plastic, like I'll need a hot glove because mine's glass. You guys will be fine like grabbing the top, but when you're microwaving it, you're gonna microwave it in small bursts because once it starts boiling, it can boil super quick. We flash boiled in our microwave at home one year doing this, like my husband and I. Anyways, so once it starts boiling, it boils quick. So if you give it like 10 to 15-second bursts in the microwave and pause and stir it, what you should see at the end when it's done is it's clear. It's not gritty, it's not white. Everything is dissolved and the solution is clear.
So is
Okay.
it like do it 10 seconds or
Like
15?
like 10 seconds, 10
Okay.
seconds, 10 seconds. That's what I tell my students because I don't want to take any chances of them leaving it in for like 30 seconds and then it's too much. Like
Right.
this should go clear. I would say probably within a minute, depending on your microwave, you know. So it doesn't take long to microwave it till it's clear, but um it can boil quick. So I don't ever take any chances. So I'm gonna go boil mine in the microwave. Um, but it
And
should
it's okay to put this in microwave that we'll use for
your
food?
your
Okay.
yes.
Okay.
Agarose is actually in I think some different like natural like gummy bears like an agar is.
Right, right.
So
Okay.
yeah. So I'm gonna warm mine up and I'll come back.
Tricia, does it have to boil or that?
Mine boiled a little at the end, but as long as it's stop's not that hot. As long as it's clear, it's good. Like everything needs to be dissolved.
I think it is. Okay. I have little boiling bubbles, but it didn't actually boil. But I don't see any of the white powder stuff in it anymore, so.
Yeah, it should be good. I mean,
Yeah,
this
mine's the same with the little bubbles, but I don't see any
It's clear.
sediment either.
yeah,
So.
as long as and it's a little hard to tell, I guess, if it's clear with the plastic as opposed to the glass, but
Because the bottom shows clear.
yes.
Yes.
Okay.
So, what you're gonna do with this agarose gel is you need to grab your box and put the comb in the box, maybe like a finger width down. If you read the directions in the book, wait, who was this? Biorad? I think Biorad. It it describes all these different things and cutting the gel and all this stuff, but we're gonna make it as easy as possible. And it gives measurements of where to put stuff, but this is the easiest. So if you guys, it's gonna be like about a finger width
One side.
comb in from one end for you guys. And then what you're going to do is you're going to take your hot agarose 1% solution, and you guys are going to start to pour it into the box. And what you should see is it coming up to those combs, but it should not over like yours. See, my solution is only about halfway up those little comb prongs. So that's about where your guys's should be. And then we just let it sit and it will solidify. And once it has solidified, what we're going to do is take the rest of our TAE buffer and pour it on top of the solidified gel. Or take the blue, I don't know if yours are all blue, but the combs, they're all blue. Okay. So take those, once it's solidified, we'll take those out. We'll pour the buffer on top till it's full. Or maybe like halfway up the rest of the space. And just close the thing, the box. We can put it in the baggie and it'll be good until next week.
So we are only preparing the gel today.
We're only preparing the gel today. It takes a little while to solidify. So that's why we'll do part 1, and then next week we get to do the fun pipetting and loading the gel. Do you guys, while we're kind of waiting for the stuff to solidify, do you have questions about the math or?
So now the gel will not be contaminated if I put in the fridge because I have something other stuff on here.
No, I would wait till it's solidified, take the thing out, the comb out, put the TAE on, close the box, and then you can actually even put it in your gel electrophoresis baggie
and then place
and then put it in the fridge.
Okay.
How long does it take to solidify? You said not long, like 2 minutes or 2 hours?
No, it'll take I don't know, 20 minutes, 15, 20 minutes.
Okay.
What do you
Okay,
think,
so
Megan?
this is something
Yeah.
we'll still do today with you.
Can you say that one more time? I'm sorry.
Is this still something we'll wait for it to solidify and take it out and then pour the other
Yeah, we
as
can,
a group, or you're just
yes, we can definitely do that. I mean, we have 30, 35 minutes left until 6:15.
okay,
So
but this, yeah,
we'll just keep on holding on together. And
but I
that's
mean that's all that's needed. Okay.
yeah, that's it.
Oh, well then.
And then if you guys have questions about anything, let me know. Anything about gel electrophoresis in general. If you want, we can look ahead at kind of like the setup for the batteries and kind of look at what we'll be doing next week.
Does the thickness of the gel matter? Like, I mean, I know that's going to determine how fast it solidifies, but when you're running the gel, does it matter how thick it is?
No, what matters is how much agarose you put in. So for this, we added 0.7 grams to make a 1%. If you added 1.4 grams, if you doubled it and made a 2% gel, it would solidify faster, and it would also be used for like smaller molecules, like smaller pieces of DNA, because I don't know if like thick is the right word, but the more
Viscosity.
concentrated the agarose gel will be. Like this one, if you actually like if you make one and hold it, you can kind of bend it a little bit, but like a 2% gel is pretty solid feeling. So like all the pores, if you haven't, oh, let me find it. Hang on. Okay. The best way I can describe a gel, if you've never looked up what agarose looks like, under a microscope, agarose actually looks like a car filter, an air filter, like a sponge maybe. And so there's all these pores and it's like very webby. So the more agarose you put in, I guess like the more webby, thick
The
the sponge
tighter the
would be,
web.
tighter the web. Yeah, that's good.
Yeah.
Um, so DNA molecules that are really big aren't going to be able to travel through that tight web. The smaller molecules will be able to, but like a 1% gel is a pretty typical um, gel size for normal kinds of things. Next week, we're going to be doing electrophoresis with the dyes and with the dyes that are on Skittles candy. So if you think back to Kool-Aid chromatography, chromatography itself, like, is an incredibly powerful science tool. So we did chromatography, what you guys did last week, with kind of like polarity and the blue molecule and the red molecule of the Kool-Aid. Those are different size molecules. This gel electrophoresis is going to do the same thing with the blue, red, yellow, orange, I think, or yellow 6 and yellow 5. It's going to do the same thing. And if you look in the binder, you can find a picture. I don't know where it is. There's a picture in the binder of those dyes. Oh, I found it. This picture, and it shows the structure of the dyes. And so you can see the dyes are different size shapes. So depending on the size of the molecule, they'll be able to travel further or
Faster.
not as far
Mhm.
based on the gel.
Okay.
Does that make sense?
It does. Thank you.
So we're using chromatography in a sense for gel electrophoresis to also separate dyes, but then when you use it for like science or forensics or something like that, or looking at DNA comparisons, if you took my DNA and any of your DNA, our DNA fragments would separate out differently. So you can look at like ancestry, how closely related certain organisms are, not just like human people ancestry, but like birds to crocodiles or something. And then or forensics like paternity tests, like Jerry Springer, all that.
Mhm.
So it's super cool. The students really, really love gel electrophoresis. You can even find some, like, I think it's a kit from Flynn it says like something to die for,
It's
like
called a process to die for.
process to die for,
Yeah, I've got that
DYE.
kit. I
Um,
use it.
but some of those dyes you can look up and you can order, um, let's see, wait, you can order positively charged molecules or dyes, because what we're going to be doing is all of these dyes that we have in the Skittles and in the tubes that we'll use next week are negatively charged. DNA is
Yes,
negatively
negative.
charged. So they're going to run, when we set up the batteries, they're going to run from the wells down,
Or
from
towards
the
positive.
negative towards the positive. But there's labs that you can set this up where you put this comb like in the middle and you can do the different charged dyes and stuff will run both ways. So if you teach physical science or anything like that, and you're talking about negative and positive repelling or attracting, it's a good demonstration for that and looking at the molecular structure. Does that make sense?
It does. Do you, by any chance, know the page that has the pictures of the molecules that you just showed me?
When you get to some numbered pages, it's 11.
Okay. I'll write that down.
But it's like near the back of this lab.
Okay.
So it's quite a few pages back.
Oh, I found it. Okay.
Yeah.
Cool.
And then we can talk about it next week too. And I've given Megan the lab, but my husband and I have made 2 different labs with gel electrophoresis with food coloring. One of them is a cladogram based lab where we have 4 or 5 birds, like a cardinal, a chickadee, a wood thrush, a bluebird, and I don't know, some other bird. And then each of the colors represents like a protein. And what they end up finding out is that the 2 birds that look nothing alike, which is the wood thrush and the bluebird, are actually more closely related, and like the cardinals, the out group. And so they can kind of put it in a table and make a cladogram based on just food coloring mixtures. And then the other one we made is in regards to environmental DNA and ecology, and but using like molecular ecology. So it's looking at invasive species and native species in areas. So like they have these food coloring samples that are like DNA samples from different parts of a watershed. And then they see, oh, the Asian carp is present in this part, and the Etowah darter and the Coosa Creek shell are present in these. And oh, shoot, like site 6 has all 3. What does that mean? Like we need to monitor that site to see how these native endemic species are being affected by the invasive species. And it's the same thing with just different dye mixes, and it's super cool.
Tricia, I've actually done that lab, but I
You
changed
did?
it. I did, yeah, but I've changed it to invasive pythons in Florida.
Yes.
So I did pythons and then some endemic species of birds, and they had to figure out where each animal was and see how far the invasive
Oh,
python had moved farther north into Florida. Yeah, I really like that lab, but I like the snakes.
yeah.
So I
It's
changed it to snakes.
it's so cool. Like just the process itself, depending on really teach almost anything. You can just mix up some food coloring and have your samples. It's really cool. It's really neat, versatile.
So when you do it, you just use food coloring because I've been using that kit, the process to dye for kit, and one of the dyes in there just doesn't work very well. It's whichever one runs the farthest.
I
It's
forget.
supposed to be the smallest molecule, but it doesn't show up hardly ever. So,
For the eDNA one with 3 species, I just use red, blue, and yellow
okay.
because, and then match the colors up to the sizes of the DNA um, of the different species. And
Right.
anyways, yeah.
I just didn't know you could do it with regular food coloring.
Yeah, you need to dilute it. Otherwise, it's like super thick color bands. But like one, I don't know, 20 to 40 microliters and like maybe 200 of water dilutes it enough. Um, Sometimes I have some of my kids that are done faster, like make some gels and play around with different concoctions so I can see how far they travel. And they like figuring it out. So,
Yeah, that's cool.
do you guys have any questions again about the math, about what we're going to do next week, gel electrophoresis? Just so you know, TAE stands for tris acetate EDTA. Other than that, I just know it's a buffer to help that electricity and stuff run through um, the gel. But that's what it stands for. For all my biology people, I feel like it's very much like FADH2.
Mhm.
What does it really mean? I don't know.
I have it. Yep.
You know, but it carries those hydrogens. So, and my stuff's still pretty liquidy.
Yes.
I had ice in my room, so I cheated and set it on ice.
Oh, nice. Is it pretty good now? Oh, you win.
Well, I'm home in my kitchen, so I know I have ice. That's a doable option.
Yeah, you or put it in the fridge for a little bit and it'll solidify faster.
Okay.
I'm in my class and the janitor keeps coming by, like looking in to see if he can clean my room yet.
Megan, I have a quick question, or
Yes.
really anybody. Just because I was on fall break, and so I did not reset my alarm for this week. But my alarm for the training went off in class because I was in Panama City, so I was in Central Time last week. But then I forgot to reset it for afterwards. So anyway, so I was a little late. So
Okay.
the I think when I logged on, I think you were talking about the equipment scavenger hunt or something to fill out. Where do I find that?
It's in the Google Drive.
Oh,
So if you just go in the main folder, there is now a PDF that says BTTI equipment survey.
yep. Thank you.
Yep. And then that has the link to the Microsoft form in it. So
Great. Perfect. Thank you.
no problem. Shakira's is looking a little cloudy. It might be solidifying. It's getting there. A little sloshy, maybe.
Gretchen, do you want to hold yours up so everybody can see what it should look like?
When it gets done.
Yeah, it kind of goes back to a cloudy, opaque-ish.
Hang on. I already added the liquid to the
That's
top of
okay.
it. Do you want me to pour it out and show you?
No, no, no. You can just
Okay.
maybe hold it up sideways.
Okay.
Yeah, so you can see the gel is kind of cloudy there and solid. And then just in case ours aren't all solidified, Can you see like on the right of the screen where her wells were? Like you can kind of see that lighter area where the comb was poked down. I don't know if you guys can see that. And then she just put the liquid about halfway from the gel to the top of the container. And that would be perfect. And then you can put it in a baggie and put it in the fridge.
Yes.
Thank you, Gretchen.
Here.
Or if it's taking its sweet time, put it in the fridge and when
Yeah.
it's solidified, come back and pop out the welcome.
Now can we take it to the fridge?
Yes.
It'll definitely be okay overnight. Like if you leave it in the fridge and go home and then tomorrow you pop out the comb, it'll be okay. It might pick up a little lint, but it'll be okay.
The other thing I found is that if your school or classroom has any roaches, they really love the agarose. And you can see little chew marks in it if it's not wrapped.
Closed.
I'm not kidding.
That's terrifying.
I have not ant traps. I have roach traps. Not but I haven't had any roaches in my room in like 2 years. But before then, sucker had to go in a bag or the roaches would bunch on it.
Ugh.
I'm leaving it in the fridge. It's still liquidy.
Sounds good.
And it's almost.
Yeah, mine was still pretty warm when I carried it to my refrigerator. So
Yeah. I don't know. It takes a little while. This is where if you guys choose to do any type of electrophoresis and you're planning ahead, um it would be worth maybe having like showing some students and maybe having them pre-make the gels the day before you want your whole class to use them. Like if you have some trustworthy students or you can make little bigger batches and pour them in multiple boxes. But it definitely would be some prep in the before the lab. Especially if you're on like a skinny schedule. Is there anything else, Megan, that you can think of?
I think we're good for today. So, when you guys are comfortable leaving your gel, we can we can dismiss for today. Yeah. So as long as you guys go back, if you're walking away from it today and going home, just come back tomorrow, wiggle the comb out, pour a little buffer over it, and then close it, bag it,
Fridge.
and keep it till next Tuesday. Yeah.
All right. I think I'm going to sign off now.
All right.
right.
Perfect.
okay,
Y'all have a
thank
great
You
night
guys have a great night.
and see
Thank
you
you.
next week for the last session.
Thank you.
Oh, do we need to send any pictures today?
No.
Okay. Bye.
Let
Bye.
us know if your gel doesn't set.
Okay.
All right, and I'll stop recording.